Hello everyone. So let's start with the today's topic, that is Arithmetic-Geometric Progression. So what is the topic? Is Arithmetico-Geometric Progression, AGP. So what is AGP? AGP is not a sequence, it's a series in in each term of which is formed by multiplying a corresponding term of an AP and GP. So what is the definition of AGP? A series in each term of which is formed by multiplying corresponding elements or term of an AP, means arithmetic progression, and GP, geometric progression. What does it mean? Like if we have an AP which is 1, 3, 5, 7 and so on, and we have an GP which is 1, x, x square, x cube and so on, then what is AGP? AGP will be 1, 3x, 5x square, 7x cube. Clearly we can see 1 into 1, 1, 3 into x, 3x, 5x square, 5x square, 7 into x cube, 7x cube, and so on. So, if I want to write the nth term of AGP, then what it will be? It will be a plus n minus 1 d. This is the nth term of an AP. Okay, and r raised to the power n minus 1. This is the nth term of an GP. Okay, so if I want to find the sum of the, if I want to find sum of m terms of an AGP. So Sn will be a, first term is a, second term is a plus dr, third term is a plus 2 dr, r square plus, and what will be the nth term? Nth term will be a plus n minus 1 d multiplied by r raised to the power n. Okay, so now if I am multiplying this equation with r, then what will we get? Rsn will be ar plus a plus dr square plus and so on. The n minus 1 term, what it will be? A plus n minus 2 d r raised to the power n minus 1 plus a plus n minus 1 d multiplied by r raised to the power n. This is equation 1 and this is equation 2. So s minus r Sn will be, if I am, so a is the same, multiplying, if I am subtracting this term minus this term, then what it will be? Dr. This term into this term, what it will be? dr square plus and so on. This term minus this term dr raised to the power n minus 1, and this is minus a plus n minus 1 d into rn. So Sn 1 minus r, which is equals to a, it's same. If I'm taking common dr, then what it will be? 1 plus r square plus n minus 2. Clearly? Okay. So now this is in GP with the common ratio r. So the sum of this GP will be 1 into how many terms in this? N minus 1. So it will be r n minus 1 upon r minus 1 minus a plus n minus 1 d. Okay. So now if dividing both the sides with the 1 minus r, then what it will be? A upon 1 minus r plus dr. If I am multiplying this term in numerator or denominator by minus 1, then what it will be? 1 minus r raised to the power n minus 1 upon 1 minus r from here. And if I am dividing both the terms with the 1 minus r, then what it will be? 1 minus r square 1 minus a plus n minus 1 d upon where r is not equals to 1. So this is the formula of the sum of the arithmetic-geometric progression, AGP. So now if mod of r is less than 1, then n tends to infinity, r raised to the power n, then limit n tends to infinity, r raised to the power n tends to 0, and limit n tends to infinity, and r raised to the power n also tends to 0. Okay. So now s infinity will be a 1 minus r plus dr 1 minus 0. So it will be 1 minus r whole square minus this term into r raised to power n. If r raised to 1 tends to 0, then this whole term tends to 0, then it will be 0. So this is the formula if r is less than 1 and n tends to infinity. Then we can find the sum of the arithmetico-geometric progression. So now we have a question like I'm writing here. Find the sum of the series 1 plus 3 by 5 plus 7 by 5 whole square plus 3 by 5 square 7 by 5 cube plus 2 n terms. So how we can find that? Let us assume this is the arithmetico-geometric progression, because what is arithmetic progression? 1, 3, 5, 7 and so on. And what is geometric progression? 1 by 5, 1 by 5 square, 1 by 5 cube, and so on. So what we have to do, let s is equals to 1 plus 3 by 5 plus 5 by 5 square plus 7 by 5 cube plus this is 2n minus 1 upon 5 raised to 5. If I am writing here rs, sr, s, what is s? S is this, or is 1 by 5 common ratio of the GP. So 1 by 5 s, which is equals to 1 by 5 plus 3 by 5 square plus 5 by 5 cube plus 7 by 5 4 and so on. 2n minus 3, 5 raised to the n minus 1 plus. Okay, so s minus 1 by 5, s is what it will be? It will be 1 as same, then plus this minus this, then what it will be? 2 by 5. This minus this, what it will be? 2 by 5 square. 2 by 5 cube. 2 by 5 raised to the n minus 1 minus 2n minus 1 into 5 raised to the power n. So this is 4 by 5s, then it will be 1 plus 2 by 5 plus 2 by 5 square and so on. Okay, so this is an GP, then the sum of the GP. A, what is R? R is 1 by 5, and how many terms in this? N minus 1. Minus 1. It will be 1 plus 2 by 5 is same clearly. So this is 1 upon 4 by 5. 1 by 5 minus 1 is equals to minus 4 by 5. Then uh, we are taking upside the minus, then what it will be? 1 minus 1 upon 5 raised to power n minus 1. 2 by 5 is here. Then this is 2n minus 1 into 5 raised to the power n. Okay. So 4 by 5 is equals to 1 plus 2 by 5 dot 5 by 4, and what it will be? It will be 5 raised to the n minus 1 minus 1 upon. Okay. And this is 2n minus 1 into 5 raised to the power. This is 1 by 2. So 4 by 5 is 1 plus 1 by 2, 5 raised to the power n minus 1. This is 5 not s. So s will be 5 by 4, 5 by 8, 5 by 4, 2n minus 1 into 5 raised to the power n. This is equals to 5 by 8, 1 upon 5 raised to the power n minus 1 minus 2n minus 1 dot 4 dot 5 raised to the power n minus 1. This is the required sum of the AGP. Now we have to find. Now the another question is evaluate 1 minus 3x plus 5x square minus 7x cube and so on tends to infinity. Now where x is less than 1. So clearly we can see that 1, 3, 5, 7 and so on are in AP and 1 minus x square minus x cube are in GP with common ratio minus x. Okay. So now we have to find the sum up to infinite terms where x is less than 1. So we know the formula of this, like Sn is equals to a upon 1 minus r plus dr upon 1 minus r square. So what is a here? A is first term, it will be 1. What is 1 minus r? 1 minus minus x plus what is d? D is 2. What is r? R is minus x upon 1 minus minus x whole square. Then what it will be? 1 plus x minus 2x upon 1 plus x whole square. Then what it will be? So if I'm taking the LCM, then it will be 1 upon x square. Then here 1 plus x minus 2x. So plus x whole square. So what will be the Sn? Sn is 1 plus x whole square. Okay. So now we have another question. Where x from s1 to 1. So clearly s is equals to 1 plus 2x plus 3x square plus 4x cube and so on. So what is xs? Xs is equals to x plus 2x square plus 3x cube plus 4x4 and so on. So by this is equation 1, this is equation 2. Equation 1 minus equation 2, then what it will be? What we get? 1 minus x as this is the 1 plus x plus x square plus x cube plus so, and what is this? This is 1 upon 1 minus x. So s is 1 upon 1 minus x whole square. This is the required sum of this series. We have another method to find this series, because first of all we know that this is method number 2. We know that summation x raised to the power k बराबर 0 to infinity, which is equals to 1 plus x square and so on. It is 1 upon 1 minus x. So if I am differentiation by differentiation, then what will we get? We are getting बराबर 1 to infinity k x raised to the power k minus 1, which is equals to 1 upon 1 minus x whole square, and this is same for required data in the question. Same. So this is method number 2. By the differentiation of this series, we will get the sum of this series. Okay. Thank you.